In this video, we're going to look at ionic nomenclature. Nomenclature just means a naming system. We're going to name cations, anions, ionic compounds, and write their formulas. Naming cations is a piece of cake. Cations are positive. And so we could say, let's use sodium, for example. We could have a sodium atom. And the symbol is just Na. The sodium atom is neutral because we have 11 protons and 11 electrons. Neutral. If I mean for it to be an ion, we just say sodium ion. And the symbol then would include the charge. Sodium forms a +1 ion. We still have 11 protons. But if we lose the 1 valence electron, there are only 10 electrons. There's your sodium +1 ion. Not bad. The negative anions are not much more difficult. Oh, let's say we have, let's get crazy. How about oxygen? You could have an oxygen atom. And the symbol is just O. It's neutral, so there's no charge. Oxygen is element number 8, so there would be 8 protons and 8 electrons. If I mean for it to be the oxygen ion, the negatives will change their ending. They'll all end in IDE. So oxygen turns to oxide ion. And then again, the symbol would include the charge, -2. It's -2 because oxygen has 6 valence electrons. We'll gain 2 to get a full shell of 8 valence electrons. We'll still have the 8 protons, but we'll have a total now of 10 electrons in the atom. There will be 2 electrons in the 1s, and then there'll be 8 electrons in the second energy level. 2s2, 2p6. For an overall charge of -2 if we gain 2 electrons. I'm not going to pick too much on spelling at first here. A lot of them are kind of predictable. Oxide, fluoride, sulfide, chloride, nitride, phosphide. They're things that you've heard of before. If you want to name a compound then, binary compounds just have 2 elements. All you do is put the 2 ion names together. The first ion in a compound will always be the positive cation, and you just write the name in full. So this is barium, and then oxygen turns to oxide. Barium oxide, done, that's it. Sodium stays the same, and then fluorine turns to fluoride. Fluoride instead of fluorine. And finally, calcium. And this would be chloride. Done. Super easy, right? The first element is the cation. You just write its normal name. The second element is the anion, the negative, and you change the ending to IDE. Now, I will never make you memorize the symbols to the elements. I'll always give you a periodic table. So if you do get an element and you're not sure what the symbol means or how to spell it, just look it up. I'll always give you a periodic table. Now, what if we want to go the opposite? We have the name and we want to write the formula. This is important. You'll be writing ionic formulas for the rest of the entire course. So if there is one skill from first semester that we want to master, It's the art of writing these ionic formulas. It should eventually be something that you don't even think about. So easy. First thing we need is the charge. And so remember, we had our periodic table, and we said there is a little trend in charge. So for example, here's kind of a makeshift periodic table. Here's my transition metals. And then I go 1, 2, 3, 4, 5, and 6. There's a great looking periodic table. Well, kind of. We get the point. The first thing I would do when I have a periodic table is write in the charges. So everybody in the first group is +1. Everybody in the second group is +2. We'll deal with the transition metals later. For now, we're going to skip them. The trend in charge, hard to predict. But when you hop across to the boron family, everybody's +3. The carbon family could go either way, and I'll show you how that works, +or -4. But then that's the transition to the negatives. -3, -2, -1. No charge on the noble gases. That's exactly what I would do. The first thing I would do when I get a periodic table for a test or quiz. Write those charges in. Now you look up the charge on both ions. Aluminum is under boron, so aluminum's charge is +3. Bromine is a halogen -1. Okay, so ionic bonds involve a transfer of electrons. Someone is the donor, that's the positive ion. Someone is the acceptor, that's the negative ion. There will always be a positive and a negative. You could never bond two positives together or two negatives together in an ionic bond. In an ionic bond, there needs to be a positive and a negative ion so that there's an electron donor and an electron acceptor. Now, all electrons need to be accounted for. They need to be completely transferred. So if aluminum's charge is +3, that means aluminum wants to lose 3 electrons. Bromine -1 means that bromine wants to gain 1. But then we have 2 electrons that aren't accounted for. To make sure that all of the electrons are transferred, these charges should add up to 0. And so we might have to do a little math to make the charges add to 0. So for example, what if I multiply this -1 times 3? Then I have a +3 and a -3. If you need to multiply the charge times 3 so that they'll add up to 0, that becomes the multiplier or the subscript in your formula. So we would write this as AlBr3. We need 3 bromine to make this neutral. On a small scale, here's what's happening. Aluminum wants to lose 3 electrons. Each bromine can take 1. So if we have 3 atoms of bromine, each will take 1 electron from aluminum. The electrons are completely transferred. Ah, I get it. Magnesium nitride. So you got to find magnesium. Magnesium is in group 2, +2. Nitride comes from nitrogen -3. Aluminum wants to lose 2 electrons, but nitrogen needs 3. We need these charges to add up to 0. Sometimes you might have to multiply both of them. So for example, the common multiple here would be 6. So let's go +6 -6. If I have 3 atoms of magnesium, I'll transfer a total of 6 electrons. 2 atoms of nitrogen, each can take 3 for a total of 6. So again, those multipliers then become your subscripts, Mg3 and 2. The subscripts in your formula. The little subscripts are the numbers that tell you how many atoms are in that compound. Not bad. And the last ones. Magnesium oxide. Magnesium is also in group 2. Magnesium twice. Both plus 2. Oxygen family is -2. That's neutral right away. Magnesium will lose 2 electrons. Oxygen wants to take 2. It's perfect. If it's neutral right away, your formula is just MgO. Done. 1-to-1 ratio. Well, that's not so bad. Or like the last one. If carbon is the first element, then you'd probably use it as the +4. If carbon is in the back, it's probably the -4. And here, the ending has changed. Instead of carbon, it's carbide. So calcium is again +2. Carbide would be the -4 version of carbon. To make this neutral, we'll take 2 calcium. +4 -1. Ca2C. Well, there you go. If you can find the charge, all you have to do then is figure out what will it take to make this compound neutral. Those little multipliers become your subscripts. It's all about complete transfer of electrons. The number of electrons donated, the positive charge, has to equal the number of electrons gained, the negative charge. Now there are a couple sheets in here then that have lots of practice. Practice writing the formula and practice writing the names. These are 1,000,000% practice. However, that's the kind of stuff you're going to see on the test and quiz. So I would take a little time, pause the video, and try some of these. Use your periodic table, write the charges, make them neutral, and then bring the video back to see the answers. This should be something that you've maybe done in the past, and it just takes a little review. If you don't try all of them, that's fine. If you find that you're getting them right, great. If you're not getting them right, that's a red flag to come and get some help right away, because it's not going to go away. We're going to be rewriting these formulas all year long. So again, at this point, you might want to pause the video, try a few from each section, writing the names, writing the formulas, and then bring it back to see the answer key. Alright, so here's the answer key. Writing simple ionic formulas. Check these over. When you do these on a test or a quiz, I don't need to see any work. I don't need to see the charge. I don't need to see the little multipliers. When you first start writing formulas, I think it helps to write the charges. But if you look them up and you notice that sodium and iodine are +1, -1, it's a 1-to-1 ratio, NaI. If you get that right away, great. You don't have to write the charges. And again, since we're going to write these things all year long, you'll get good at them. You have no choice but to get good at writing ionic formulas. So check these over, and again, if you need to pause it, go right ahead. If there's anything here that is not clicking, let me know. If you can write the formulas, then hopefully writing the names is pretty easy too. These guys always have 2 parts. The first element just gets its normal name. The second one changes to IDE. And again, I'm not going to pick on your spelling as long as we can tell what you mean. Notice too, there's no mono-di-tri. Sometimes people will say like magnesium dibromide or aluminum trichloride. I don't need mono-di-tri. If you tell me aluminum chloride, I know aluminum is always +3, chlorine is always -1. I can write the formula AlCl3. I don't need any other assistance to tell me the formula. all of these ions, I can find their charge on the periodic table, as long as I know the trend with charge. So again, if you need to, you can give the video a little pause, check these over, make sure you're getting them right, and let me know if there's anything here that is not going well for you.